Hi, and welcome to this deep dive on Cloud Decoded. Today, we are going beyond the basics. We are going to deconstruct the actual brain of your AWS network, subnets, route tables, and the critical associations that bind them together. If you've ever wondered why can't I reach my server, or why is my database public, this video is for you. Let's start with the atomic unit, the subnet. A subnet is just a segment of your VPC's IP address range designated for a specific availability zone. But here is the secret: a subnet is neither public nor private by itself. It is just a block of IP addresses. Its personality comes entirely from the route table. Think of a route table as a navigation map for every packet leaving your subnet. It contains a list of rules, called routes, that determine where network traffic is directed. Every VPC has a main route table, but for granular control, we create custom ones. Every single route table has one unchangeable rule, the local route. This allows all resources within the VPC to talk to each other. For example, if your VPC is 10.0.0.0/16, the local route ensures 10.0.0.1.5 can talk to 10.0.2.0 without leaving the network. So, what makes a subnet public? It is simple. A subnet is public if its associated route table has a route to an internet gateway. That is it. If that route exists, the door is open. If it is missing, the subnet is private. The route table holds the key. Let's build a public route table. We create a new table and add a route, destination 0.0.0.0/0, which represents all IP addresses. For the target, we select our internet gateway. This tells the network, if you don't know where to go locally, go to the internet. Creating the table isn't enough. It's just a floating document until we use it. This is route table association. We must explicitly select our web server subnet and associate it with this public route table. The moment we click Save, that subnet becomes public. Now for the private subnet. We want our database here. We create a separate private route table. In this table, we do not add the internet gateway route. We only keep the local route. This ensures our database is completely cut off from the public internet. Just like before, we must associate our database subnet with this private route table. Now, any instance launched here has no map to reach the outside world. It helps prevent hackers from directly accessing your sensitive data. But wait, what if your database needs to download a security patch? It needs internet access, but we don't want the internet to access IT. This is where the NAT gateway comes in. We place a NAT gateway in the public subnet. We then go back to our private route table. We add a route for 0.0.0.0/0, but this time, the target is the NAT gateway ID, not the internet gateway. The private subnet hands traffic to the NAT, and the NAT talks to the internet. Let's trace a packet. A user requests your website. The packet hits the IGW, checks the public route table, finds the web server in the public subnet, and delivers the request. The return traffic follows the same path back out to the internet. Now, your database needs an update. It sends a request. The private route table sees the 0.0.0.0 rule pointing to the NAT gateway. It forwards the packet to the NAT in the public subnet. The NAT then sends it to the IGW and out to the world. The number one mistake I see: not associating the subnet. If you don't explicitly associate a subnet, it implicitly uses the main route table. If your main table is private, your public web server will accidentally be cut off from the world. To wrap up, here is your cheat sheet. 1. Use descriptive name tags for every table. 2. One public route table can serve multiple public subnets. 3. Keep your main route table private by default to force explicit choices. You now understand the nervous system of AWS. You know how to route traffic, secure your data, and use associations to define your network. I challenge you to go build a 3-tier VPC today. Don't forget to like and subscribe to Cloud Decoded. Happy cloud computing!